Hello and welcome to this session. This session is all about growth or decay application of differential equation. Let's start. If we are talking about growth or decay application of DE, it is defined as the time rate of change of the amount x, which is the present amount, proportional to the x, meaning to say, if we let dx over dt, or this is said to be the rate of change of x, meaning to say the changes in x with respect to time, that is considered as your dx over dt, then x is to be your present amount. So for the derivation, yung definition ng growth or decay application, you have the rate of change of x, which is the dx over dt, proportional to the amount x, which is your present amount. So here's your definition kapag nilipat natin as equation. So i-equate natin, you will have dx over dt equated to kx, wherein k is what we call the proportionality constant. So i-apply natin yung differential equation by using separation of variables, meaning to say sama-sama si x, then sama-sama si t. Then si k is considered as your constant kasi our variable here, it depends kay x tapos kay t. So we will have dx over x equated to k dt. Now, doing the integral part, you will have the integral of dx over x equated to the integral of k dt. So we will have plus c. So now we will have our dx over x is ln of x, then our k dt is k t, then our plus c. Then to simplify the equation, we have to take the exponential of both sides. You will now have e raised to ln of x equated to e raised to kt plus c. But since we have the property, this side, pwede natin itong paghiwalayin. Paghiwalayan natin yung exponent, we will now have e raised to kt multiplied to e raised to c, which have the same base as e. Then magkahiwalay na yung exponent. Then dun naman sa kabilang side, all we know is if we have e raised to ln, ang matitira lang is yung angle ni natural logarithm, which is the x. So we will have an equation of x equals e raised to kt multiplied to e raised to c. But we all know that e raised to c is also considered as arbitrary constant. So e raised to c can be simplified as c. So we will have an equation as x equals c e raised to kt, wherein our x is the present amount, c is the arbitrary constant, t is time, k is the rate of growth or decay. Ngayon, paano mo malalaman kung growth or decay yung problem? If you have positive k, that is growth, and if you have negative k, you will have decay. Now, para mas madali nating maintindihan, let's go to our example. Okay, we have example number 1. The problem is, suppose that we have a chemical reaction proceeds according to the law given, which is the growth or decay application. If half of the substance A has been converted at the end of 10 seconds, find when the 9/10 of the substance will have been converted, knowing that the unconverted substance is what we know as the present amount of the substance. Ngayon, yung tinutukoy sa problem is the converted amount. So all we have to do is to identify the unconverted substance for us to know the present amount or the x value. So para mas madali, gawin natin in table. So we have the time and we also have the x, which is the present amount. So the starting time, we have 0. So syempre, magsisimula siya as a whole substance, which is A. Then after 10 seconds, it has been converted into half. So obviously, kung isang buo yung sinimulan mo at kalahati yung na-convert, we have kalahati din yung unconverted, which is the x or the present amount. So we have 1/2 of A. So ang unknown natin is to find when the 9/10 of the substance will have been converted. So since 9/10 of A has been converted, ang kailangan natin is the unconverted substance. So ang natitira pa kay substance is 1/10 of A kasi nga 9/10 yung converted. So all you have to do is to find the time kung kailan 1/10 na lang ni A yung natitira. Now let's go to the solution. So our formula is x equals c e raised to kt. So for the first condition, at time is equal to 0, the value of x is equal to a. So all we have to do is to substitute the t and the x at the equation. So we will now have a equals c e raised to k multiplied to 0. So e raised to 0 is 1. So all you have to is c equals a. So alam mo na ngayon yung value ni c, which is a. So punta tayo sa second condition wherein the time is 10 seconds. Then the value of x is 1/2 ni a. So ngayon gagamitin natin yung value ni c dun sa second condition. So our c there is a. Then you have to substitute the value of x, which is 1/2 of a. Then si e raised to k, which is the time, is 10. So all you have to do is to simplify the equation to find the value of k. Since may a ka dito at may a ka din dito, makakancel natin si a. So ang mangyayari, you will now have 1/2 equals e raised to 10k. Now, taking the ln of both sides, you will now have ln of e raised to 10k, then equals to ln of 1/2. Then through the property of natural logarithm, if you have ln of e raised to 10k, ang matitira na lang sa side nito is 10k. So you will have 10k equals ln of 1/2. Then divide natin both side by 10. Now the value of our k is 1/10 ln of 1/2. So you have the value of k. Now mahahanap na natin yung value ni time since gagamitin na natin yung condition 3 wherein the time is the unknown and the value of x is 1/10 of a. Now substituting the computed value of c and k, you will have c as a, then k is 1/10 ln of 1/2. So you will have the value of x is 1/10 of a. So your equation now is 1/10 of a equated to a e raised to 1/10 ln of 1/2 multiplied to t. So since parehas ulit may a yung both side, makakancel ngayon si a. Ang matitira na lang is 1/10 equals e raised to 1/10 ln of 1/2 multiplied to t. Now taking ln of both side again, you will now have ln of e raised to 1/10 ln of 1/2 multiplied to t equated to ln of 1/10. Same property, if you have ln of e, ang matitira na lang is the exponent of the e. So you will now have 1/10 ln of 1/2 t equated to ln of 1/10. Now, your unknown is t. So, pwede nating i-divide both sides dun sa kasama ni t, which is the 1/10 ln of 1/2. So, ang mangyayari, you will now have t equated to ln of 1/10 all over 1/10 ln of 1/2. Since t is the unknown, magkakaroon na tayo ng final answer na t is equal to 33.22 seconds or approximately equal to 33 seconds. So after 33 seconds, the value of the unconverted, which is the present amount, that is 1/10. So yun din yung time na 9/10 of the substance A has been converted. So that is our first example. Now going dun sa second example, our next example is the conversion of substance G follows the law given if only a fourth of the substance has been converted at the end of 10 seconds, find when the 9/10 of the substance will have been converted. Noted again that the unconverted substance is the present amount. So gagawin natin siya in table again. So the starting time, the value of your present amount is the whole substance G, which is G. So after 10 seconds, a fourth of the substance has been converted. So one fourth has been converted. Therefore, three-fourths of the whole substance G is the unconverted amount. Then the question is, find when the 9/10 of the substance will have been converted. If 9/10 of the substance has been converted, obviously 1/10 of the substance G, this is G, sorry for that. So 1/10 of the substance G is the unconverted substance. So, tackle natin ngayon yung solution. Same formula, you will now have x equals c e raised to kt. Though the first condition is if the time is 0 or initial time, you have the present amount, which is the whole substance G. So substituting that, you will have G equals C e raised to K of 0. So you will have C equals G. Now punta tayo sa second condition. You will now have T at 10 seconds. X is 3/4 of G. Gagamitin natin ngayon yung computed value ni C. You will now have 3/4 of G equals G e raised to K multiplied to 10. So cancel ulit si G since parehas na side meron. You will now have 3/4 equals e raised to 10k. Now taking the ln of both sides, you will now have ln of e raised to 10k equals ln of 3/4. So property again ng natural logarithm, you will now have 10k equals ln of 3/4. Now dividing both side by 10, you will now have the value of k as 1/10 ln of 3/4. Now you will use the computed value of k and c for the third condition, wherein the t is unknown, then the value of x is 1/10 of g. So you will now have 1/10 of g equated to g e raised to 1/10 ln of 3/4 multiplied to time. So canceling both g on both sides, you will now have 1/10 equals e raised to 1/10 ln of 3/4 multiplied to time. Now taking the ln of both sides, you will have ln of e raised to 1/10 ln of 3/4 multiplied to t equated to ln of 1/10. So property again ng natural logarithm, mawawala si ln e. Matitira na lang is the exponent of the e. You will have 1/10 ln of 3/4 multiplied to time equated to ln of 1/10. So para makuha natin si time, i-divide natin siya dun sa kasama niyang coefficient. So t is equal to ln of 1/10 all over 1/10 ln of 3/4. So the value of our time, wherein 9/10 of the substance will have been converted, or should we say 1/10 of the amount G is the present amount, you will have time is 80.09 seconds, or approximately 80 seconds. So after 80 seconds, the amount of your substance G is 1/10, wherein 9/10 have been converted. So next example, we have radium decomposes at a rate proportional to the quantity of the radium present. Suppose that it is found that in 25 years, approximately 1.1% of a substance of a certain quantity of radium has been decomposed. So 1.1% of the radium has been decomposed after 25 years. To determine approximately how long will it take for 1/2 of the original amount of radium to decompose, or yung tinatawag natin na half-life nung radium. So noted again that the unconverted substance is your present amount. Now, identify natin ngayon yung table. So the starting time is 0. Tapos, the present amount at the starting time, let's say you have the whole amount of radium, which is the 100% of radium. Then, after 25 years, 1.1% yung nawala. So, if 1.1% yung nawala kay radium, ang natitira pa is 98.9% of the radium. Now, if we have to determine kung 1/2 yung nawala, so obviously 1/2 yung natira, which is 50% of the radium, yun ngayon yung hahanapin nating time. So, let's go to the solution. Our formula again is x equals c e raised to kt. So, for the first condition, time is equal to 0 and x is equal to 100% of the radium. So, if we have 100% of the radium as x and 0 as your time, you will have 100% Ra equals c e raised to k of 0. Therefore, our c is 100% of radium. So, for the condition 2, you will now have time of 25. Then our x now is 98.9% of the radium. So, gagamitin natin yung computed value ni C. Dun sa equation, you will now have 98.9% of the radium equated to 100% of radium e raised to k multiplied to 25. So, mahanap na natin yung value ni k. So, we will have 98.9 all over 100 since makakancel ngayon yung percentage and the RA, you will have equated to e raised to 25k. Then taking the ln of both sides, you will have ln of e raised to 25k equals ln of 98.9 over 100. So, magiging 25k na lang equals ln of 98.9 over 100. So, the value of our k is 1 over 25 ln of 98.9 all over 100. Since you have the value of k and you do also have the value of c, gagamitin na natin siya kay condition 3 wherein the time is our unknown and our x is 50% of the radium. So you will now have 50% of the radium equated to 100% of the radium e raised to 1 over 25 ln of 98.9 over 100 multiplied to t. So the unknown is your t. You will now have 50 over 100. So cancel si RA ulit. Equated to e raised to 1 over 25 ln of 98.9 over 100 multiplied to t. Taking again the ln of both sides, you will have ln of e raised to 1 over 25 ln of 98.9 over 100 multiplied to t equated to ln of 50 over 100. So you will have this exponent, yun na lang yung matitira. So you have 1 over 25 ln of 98.9 over 100 multiplied to t. Equated ngayon siya kay ln of 50 over 100. Now, to find the value of t, you have to divide the whole equation dun sa coefficient ni t. So you will now have t equals ln of 50 over 100 all over 1 over 25 ln of 98.9 over 100. So the computed value of t is supposedly 1,567 years, since our time is in terms of years, or approximately equal to 1,600 years. Or should we say the half-life of the radium is 1,600 years, wherein 50% of the radium has been converted, then the 50% is the unconverted of substance of the radium. Then next example, we have number 4. So example number 4, again, a bacterial population R is to have a rate of growth proportional to R itself if between noon and 2 p.m. the population triples. At what time? No controls being exerted. So ibig sabihin, nakabase lang siya dun sa law given, which is the rate or decay application of the differential equation. Then should it become 100 times, meaning to say the unconverted substance is again the present amount. So let's say starting time is 12 noon. So you have 0 time. Then the present amount of the population is R, or our bacterial population is R. So after 2 hours, that is between 12 noon and 2 p.m. So that's 2 hours. the population triples, meaning to say, matitriple yung present amount natin dun sa starting time. So we will now have 3R. So the question is, at what time wherein it become 100 times ni R? So let's go to the solution. You have the formula again, x equals c e raised to kt. Our condition 1, at 12 noon, the time is 0, and the value of our x is r. So, isa-substitute natin siya ngayon. You will have r equals c e raised to k of 0. So, the value of our c is now r. Now, for the condition 2, at 2 p.m., the value of t is 2, and the value of x is 3r. Now, substituting the computed value c, then the condition, you will now have 3r equals r e raised to k of 2. Then you will have to cancel r. You will have 3 equals e raised to 2k. Taking the ln of both sides, you will have ln of e raised to 2k equals ln of 3. So, mawawala ngayon si ln saka si e. You will have 2k equals ln of 3. Then the value of our k is 1/2 of the ln 3. Now we will use the computed value of k and the computed value r dun sa third condition para mahanap natin ngayon si time. Now t is unknown, x is 100r. You will now have 100r equals r, which is your c, e raised to 1/2 ln of 3, which is your k, multiplied to t. Now you will have to find the value of t. Canceling your r, you will have 100 equals e raised to 1/2 ln of 3 multiplied to t. Taking the ln of both sides, you will now have ln of e raised to 1/2 ln 3 multiplied to t equals ln of 100. Now ln e, ang matitira na lang is the exponent, which is 1/2 ln 3 multiplied to t equal ngayon kay ln of 100. Now, i-divide natin siya sa 1/2 ln 3. Ang magiging equation natin is t equals ln of 100 all over 1/2 ln 3. Now, the value of our t is 8.38 hours. So, after 8.38 hours, the value of your population is 100 times of the original population. So, that is the time in terms of hours. But if we need to find the exact time wherein the population is 100 times of the original, we have to convert the 0.38 hours in minutes. So you will have 0.38 hours multiplied to 60 minutes per hour. That is equivalent to 22 minutes. So the exact time, if the reference time is 12 noon, your answer is 8:22 p.m. So at 8:22 p.m., your population is 100 times of the original population of the bacteria. Last problem for this session. Example number 5. A certain radioactive substance has a half-life of 38 hours. So find how long will it take for 90% of the radioactive substance be dissipated. So yung nawala. So ibig sabihin, yung unconverted substance, yun pa din yung present amount natin. So yung dissipated, yun yung converted substance. So if your reference time is 0, so obviously you have the 100% of the substance. So after 38 hours, when we say half-life, 50% of the substance has been converted or dissipated. So meaning to say 50% ng substance is the unconverted. Since 50% ngayon nawala, obviously 50% din yung matitira. So if 90% of the substance is dissipated or converted, so obviously again, 10% of the substance yung unconverted. Now the question is, kailan magiging 10% na lang ng substance yung unconverted? So wherein 90% has been dissipated. So for the solution, you have the same formula as x equals c e raised to kt. The condition 1 is time is equal to 0 and the value of x or the substance is 100%. So you will have 100% equals c e raised to k of 0. Therefore, the value of c is 100%. Now, for the second condition, at time is 38, the value of your x is 50%. So, gagamitin natin yung computed value c, that is 100%, e raised to k of 38, which is your time, equated ngayon kay 50%, which is the x. So, makakancel si percentage. You will have 50 over 100 equals e raised to 38k. Taking the ln of both sides, you will have ln of e raised to 38k equals ln of 50 over 100. So, 38k equals ln of 50 over 100. So, the value of our k is 1 over 38 ln of 50 over 100. Now, using the computed value k and c, dun sa third condition wherein time is unknown and x is 10%, you will now have 10% equated to 100% e raised to 1 over 38 ln of 50 over 100 multiplied to t. So cancel against the percentage, you will have 10 over 100 equated to e raised to 1 over 38 ln of 50 over 100 multiplied to t. Taking the ln of both sides, you will have ln of e 1 over 38 ln of 50 over 100 multiplied to t equated to ln of 10 over 100. So you will have 1 over 38 ln of 50 over 100 multiplied to t equated to ln of 10 over 100. Then para makompute natin si time, you have to divide both equation or both side dun sa coefficient ni t. You will now have t as equal to ln of 10 over 100 all over 1 over 38 ln of 50 over 100. So the computed time is 126.23 hours. So for the final answer of this problem, wherein 10% of the substance is the unconverted amount or 90% has been dissipated in the substance, that is after 126.23 hours. So that's all for this session. I hope you learned a lot about growth or decay application of the differential equation. If you have any question, comment down below your question or just PM me on my messenger. Thank you and God bless.